Hi everyone, it's Orkan. Today we have a problem when we are given an array and the start, which is the starting index. So for example, in this case, the starting index is 3. So from whatever the value of that index, in this case, the value of the index is 1. We can jump either one step to the right, or we can jump one step to the left because the value is 1 for the starting index. So for example, let's say that we are jumping to the right and now we are at index 4 where the value is 3. So which means that from this index we can also jump either to the left or to the right 3 steps. So or from 1 we can jump also one step to the left, and the value is now at the index 2 is 10, so which means that we can jump either 10 steps to the left or 10 steps to the right from that position. So what we need to do is we need to find whether or not we can, jumping from our starting index, whether or not we can reach the index where the value is 0. If we can find that, if we can find the index with the value 0, then we are returning true. If not, then we are returning false. So how we are going to solve this problem? We are going to solve this problem using dynamic programming bottom-up approach. So what we are going to do is we are going to first create an array dp with the size of our initial array, and let's define our base cases for it. So our first base case is that if we are at any position, so we are at certain position, and if we are at that position, if the value is that if we are going beyond our array, so which means that the position is less than 0, and or if the position is more than length of our array, then in that case we are returning false. It means that we cannot reach the index where the value is 0. The second one is if the value at that position of the array is equals to 0, which means that we have found the index where the value is 0, so we are returning true. That's the first step. The next step is what we do is, that's our base cases. The next step is we are recursively calling to the left and we are recursively calling to the right to see that whether or not we can find the index with the value is 0. So for example, let's go step by step. So for example, in this case, our starting point is our starting index is 3, so which means that we are starting from index 3, and the first thing that what we do is we are jumping one step to the left, right? Position minus array, whatever the value of that array. So we are jumping 3 minus 1 gives us 2, so we are going to the second index. Now we are at the second index, and the second index, the value is 10. If the value is 10, what it means that doesn't matter wherever we will jump to the right from the second index, or where we are going to jump to the left, it will return us, it will go beyond the size of the array, which means that we cannot find the index with the value of 0 from this position. So we are going to set in our DP, we are going to set the value for that index false. Why? Because if next time we again reach the index 2, we know that starting from that index, we cannot reach our index with the value of 0, so we are setting that to false. How about the next one? The next one is that now we are jumping, we explored the left side, right? We explored the left side, now we are jumping to the one step to the right, so position plus array value of the array, right? So we are now jumping to the 4, and from the 4 again we can go to the left and we can go to the right. To the right, it will return us false because it goes beyond the size of the array. To the left, we are now at the position, so we are reaching the index where the value is 0, which we are setting that value to true, which we are returning. First thing that we do here, we are creating an array DP with the size of our array, and the next one we are creating another function can reach helper where we are passing our array, our starting position, and our array, our dynamic programming array. So what we do is, first step, we are checking that if our position, right, and if the position is goes beyond the size of our array. If it's less than 0 or it's more than the position of if it's more than the length of our array, then in that case we are returning false. That's the first our base case. The second base case is that if the position is equals to 0, if the value of the array at that position is equals to 0, then in that case we are returning true. That means that we found the position where the value is 0. And if we are passing these two base cases, then we are checking that if we already explored that starting from that index, right? If we already explored that and we found that the value starting from that index, then we are checking in our array that if the p position is not none, so which means that we have already found the whatever, can we reach the 0 starting from that position or not. Then we are just simply returning that whatever the value is there. If not, then we are setting for the DP position, we are setting the value for false. And what we do is we are exploring the options to the right, and we are to the position plus array, whatever the value is in that position, whatever the value is in that index, and we are exploring to the left recursively. And so if either of these return us true, then we are setting the value to true, and we are returning that value. So what's the time and space complexity of this solution? The time complexity is that for each index we are calling can reach helper only once, so it's of 1. For the space complexity we are using, so it should be calculated considering two factors. The first one is that for the DP, the size of DP is the size of our array, it's n, with the size of n, and another one is that our recursive call stack is at most it will be at most the size of our n, of our input. So then it's a 2 of n, so we are disregarding the constant part, and the space complexity in this case is of n. Okay, that's it. I also have the identical solution in Java. I will include that in the description. That's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.